The Chengdu J-10C Vigorous Dragon is a single-engine, lightweight multirole fighter aircraft that represents the culmination of the J-10 series development, embodying significant advancements in aerodynamics, propulsion, avionics, and weapons systems integration. Its fundamental airframe design employs a canard delta wing configuration, a layout characterized by the presence of small foreplanes, or canards, located ahead of the main wings. This configuration is not merely a stylistic choice but a critical aerodynamic feature that provides several distinct performance advantages. The primary aerodynamic benefit is the generation of vortex lift. The canards generate powerful vortices that flow over the main delta wing, delaying airflow separation and allowing the aircraft to maintain controllability and generate lift at very high angles of attack. This translates directly into exceptional instantaneous turn performance, a crucial metric in within visual range air combat maneuvering. Furthermore, the canard configuration reduces takeoff and landing distances by increasing overall lift, allowing the aircraft to operate from shorter or damaged runways, thereby enhancing operational flexibility and survivability. The structural composition of the J-10C incorporates a significantly higher percentage of composite materials in its airframe compared to its predecessors, the J-10A and J-10B. The use of carbon fiber composites and other advanced materials in the fuselage, wings, and tail sections serves to reduce the overall structural weight. This weight reduction is critical for achieving a superior thrust-to-weight ratio, which is the engine's thrust output relative to the aircraft's loaded weight. A higher thrust-to-weight ratio directly enables faster acceleration, a higher rate of climb, and better sustained energy during combat turns, preventing the aircraft from becoming slow and vulnerable. The reduction in weight also allows for increased payload capacity, enabling the aircraft to carry more fuel or a wider array of munitions without sacrificing performance. The J-10C is powered by the WS-10B Taihang turbofan engine, an indigenous Chinese power plant that represents a key milestone in aerospace propulsion. This engine provides a substantial increase in thrust and reliability over the earlier Russian-made AL-31FN engines used in initial J-10 models. The WS-10B features a full-authority digital engine control system that optimizes performance across all flight regimes, from takeoff to high-altitude supersonic flight, and provides smoother throttle response, which is vital for precise control during air-to-air refueling and weapon delivery. The core of the J-10C's modern combat capability lies in its advanced avionics suite, which is built around an integrated modular architecture. This architecture allows different systems, such as the radar, electronic warfare suite, and communications, to share data through a high-speed data bus, functioning as a cohesive whole rather than a collection of separate components. The most prominent sensor is the active electronically scanned array radar. Unlike older mechanically scanned radars that physically rotate an antenna, an AESA radar consists of hundreds or even thousands of small transmit-receive modules. These modules can be electronically steered to point radar beams in different directions almost instantaneously, without any physical movement. This provides numerous tactical advantages, including a much higher resistance to jamming, as the radar frequency can be changed rapidly across a wide band, the ability to track a large number of targets while simultaneously scanning for new ones, and the capability to perform low probability of intercept modes, making the aircraft harder to detect by enemy radar warning receivers. The effective detection range of this AESA radar against a typical fighter-sized target is considered to be substantial, providing the pilot with early situational awareness and the first look, first shot capability in beyond visual range engagements. Complementing the AESA radar is an infrared search and track system. The IRST is a passive sensor, meaning it does not emit any signals of its own. Instead, it detects the heat emissions, or infrared signature, generated by aircraft, missiles, and other objects. This allows the J-10C to detect and track targets silently, without alerting them with radar emissions. This is particularly valuable in modern electromagnetic environments where radar use can be detected and exploited by adversaries. The IRST is highly effective at closer ranges and is a critical tool for countering low observable, or stealth, aircraft, which may have a reduced radar cross-section but still emit a significant infrared signature from their engines and skin friction. The data from the AESA radar, IRST, and other sensors like the radar warning receiver and missile approach warning system are fused together by a central computer. This sensor fusion process presents the pilot with a single, coherent, and prioritized tactical picture on the cockpit displays, rather than forcing the pilot to mentally correlate raw data from multiple separate screens. This dramatically reduces pilot workload and accelerates decision-making in high-stress combat situations. The weapon systems integrated with the J-10C are selected and optimized to leverage the full potential of its advanced sensors. For long-range air dominance, the primary beyond visual range weapon is the PL-15 air-to-air missile. The PL-15 is distinguished by its extended range, which is enabled by a sophisticated propulsion system, likely a ramjet or dual-pulse rocket motor that allows it to maintain energy over long distances. More importantly, it features an advanced active radar seeker. This seeker is designed to be highly resistant to electronic countermeasures, making it difficult for an enemy aircraft to jam or spoof the missile in its terminal guidance phase. The combination of the J-10C's powerful AESA radar, which can provide high-quality mid-course updates, and the PL-15's long-range and reliable seeker, creates a formidable engagement envelope that can challenge even advanced 4th-generation and 5th-generation fighters. For close-in, within-visual range combat, the J-10C employs the PL-10 high-off boresight infrared-guided missile. The term high-off boresight refers to the missile's ability to lock onto and engage targets that are located at very sharp angles away from the aircraft's forward centerline. This capability is enabled by an advanced imaging infrared seeker and agile flight control surfaces. When paired with a helmet-mounted display and sight system, it allows the pilot to simply look at a target aircraft, designate it with a glance, and launch the PL-10, which can then execute a high G-turn to intercept the target. This look-and-shoot capability provides a decisive tactical advantage in a dogfight, as it eliminates the need for the pilot to spend critical seconds maneuvering the entire aircraft into a traditional firing position behind the enemy. The current operational status of the J-10C is that it is a fully matured and numerically significant platform within the People's Liberation Army Air Force. With over 300 units estimated to be in active service, it constitutes a substantial portion of China's modern tactical fighter fleet. The aircraft is deployed with numerous operational regiments across all major theater commands, fulfilling roles including territorial air defense, regional air superiority, and precision strike. Its combat effectiveness transitioned from theoretical to proven during aerial engagements in the South Asian region in May 2025. During these incidents, J-10Cs, operated by the Pakistan Air Force, successfully employed their sensor and weapon systems, including the PL-15 missile, against modern fighter aircraft of a neighboring state. This real-world performance provided empirical validation of the system's capabilities, demonstrating that its AESA radar could effectively support beyond visual range engagements and that the PL-15 missile was a reliable and effective weapon in a live combat environment against capable adversaries. Regarding future trajectory and international presence, the J-10C program is in a phase of strategic expansion and international market penetration. The most significant development is the confirmation by the government of Indonesia of a contract to acquire 42 J-10C aircraft in a comprehensive package that includes weapons, spare parts, training, and logistical support, with the total value of the agreement reported to exceed $9 billion. This procurement makes Indonesia the third confirmed operator of the type and represents a major geopolitical and defense industrial achievement, signaling that the J-10C is now considered a credible and high-performance option by a major Southeast Asian power. This sale has subsequently generated reported interest from several other nations across the Middle East, North Africa, and South Asia, who are now evaluating the fighter as a viable alternative to Western platforms like the F-16 Block 70, 72, and the French Rafale, as well as Russian counterparts like the MiG-35 and Su-35. The future development path for the J-10C platform will likely focus on continuous incremental improvement through software updates and potential block upgrades. These enhancements may include refinements to the AESA radar's processing power and new operational modes, further advances in sensor fusion algorithms, the integration of more powerful or fuel-efficient engine variants as they become available, and compatibility with next-generation munitions currently under development in China, such as newer air-to-air missiles with even greater range and smarter seekers, advanced standoff air-to-ground weapons, and potentially even loyal wingman-type unmanned aerial vehicles that could operate in concert with the manned fighter. The ongoing production and evolution of the J-10C suggest it will remain a cornerstone of Chinese and potentially other nations' tactical air power for the foreseeable future, with its design offering a platform amenable to continued modernization.